Hello, and welcome to the 7th episode of Sci-Five. I'm your host, Shea-Kurek. On Sci-Five, we talk about 5 significant technological and scientific innovations that happened this week. Or, we're a little bit late, so last week. This week, we'll be talking about tiny solar cells and a new innovation in microchips, allowing them to be organically assimilated, and more. Researchers at the University of Surrey have discovered a new innovation through research in moth eyes. By manipulating graphene nanostructures, scientists hope to emulate moth eye patterns, allowing for an increased efficiency for textures that absorb light. With this upgrade, graphene would be capable of absorbing 93% more light, and implementing this into solar cells could drastically increase their efficiency. Another possible use is through texturing that could be applied to your wall in a form of smart wallpaper. This smart wallpaper would allow your house to absorb any excess heat and convert it into electricity. Have you ever conceived of a computer-organic hybrid, like a cyborg? Well, today, the University of Columbia might be making that possible. In their most recent efforts, the team has created a superconductor that uses a membrane in order to absorb ATP from the surrounding areas. ATP is the molecule found inside most human and organic cells used to create energy. This new biochip would simply absorb the ATP and convert it from its potential chemical energy to electrical energy, allowing it to sustain power while inside a living organism. Transhumanists will get a real kick out of this new computer chip, and the medical field should be able to find limitless uses for analyzing data about the human body in real time. Researchers at the Massachusetts Institute of Technology have created a new tiny solar cell, so small in fact that it could fit inside a bubble. Most solar cells are created by combining 3 layers of composite material in order to absorb sunlight. In their new process, MIT has allowed for it to become one layer that contains all 3 properties needed. This process cuts down on time, increases efficiency overall, prevents contamination from other things in the combining process, and is much smaller and much lighter. It's so thin, in fact, that you could fit 50 of these things by their width, stacked high, and not even get to the size of the human hair. Although this innovation is great, it's still not viable for market purchases, which is, of course, the next step for most massive innovations. A team of Russian physicists have created a way in order to manipulate atoms at a speed of 3 attoseconds. To tell you how quick an attosecond is, it is 1/quadrillionth of a second. Most molecular connections form at that speed, allowing scientists to literally view molecules forming. However, atomic interactions on a much smaller scale are usually done in femtoseconds. So we're not quite there yet, but we're getting closer to seeing the inner workings at the speed that they happen. Researchers used X-ray electron beams in high-powered lasers to manipulate neon atoms at ultra-short frequency pulses on the femto scale. The result of this experiment, using 2 neon atoms instead of 1, created a harmonic resonation between the 2, creating a 3rd wave that could be detected at much higher speeds. Scientists expect that the more we add to the equation, the faster we'll be able to perceive these small types of reactions and interactions. Scientists at the University of Berkeley have devised a way to manipulate the spin of electrons using microwaves. By using an exotic silicon material, researchers have found that bombarding them with certain frequencies of microwaves can change an electron from an excited state to a relaxed state. Under normal circumstances, silicates don't drop in excited to relaxed states naturally, but with this process we can help it occur tens of thousands of times faster. This may not seem very useful now, but as time goes on and quantum computing becomes more reliable, qubits rely on the spin of electrons in order to do their computations. With this process, we'll be able to affirm whether or not things are relaxed or excited.